Right, when we're dealing with probabilities, there's actually two characteristics or two situations of probability that we need to be aware of. And the first one is mutually exclusive. Now, we say two events are mutually exclusive if they have nothing in common. Okay, nothing in common. So what I mean by that is if I was to draw a Venn diagram, normally there'd be an intersection point here, right? But for any mutually exclusive events, there's never going to overlap. So that means that the probability of A and B is going to be equal to just 0, like this. Meaning that the probability of A union B, A and or B, right? It's just the sum of probability of A plus the probability of B, like this. So that's what mutually exclusive is. Now, independent. So independent means that one event does not affect the outcome or the probability of the second event. And the way we show that is by looking at the probability of A and B. Right? We know from the multiplication rule, or the addition rule, sorry, the probability of A and B is equal to probability of A plus probability of B minus probability of A union B. Okay, so this is called the addition rule. And this rule works for every single scenario. Okay, it works for independent, not dependent. It works for mutually exclusive. This one rule always stands. Now, we call it independent if we work out probability of A and B again by doing probability of A times the probability of B. So basically what we do is find the probability of A and B using these two different equations. And if they're the same, that means the events are independent. If they are different, then it's not independent. So let's look at this one here. So we have S and T, which are two events. Probability of S is 0.3, probability of T is 0.4, and probability of S but not T is 0.18. So first things first, we just want to draw the Venn diagram just to visualize it a bit better. So we have S, T, S but not T, so S but not T is 0.8, this is 1.18. Probability of S is 0.3, this means this is 0.12, and therefore this is going to be 0.28, like so. I'm going to have 0.42 outside. Right, show that S and T are independent. So to show independent, we have to find the probability of S and T. We'll use the addition formula first, the probability of S plus the probability of T minus the probability of S union T. So this is going to be 0.3 plus 0.4 minus union will be 0.58. So therefore this will give us 0.12 like this. Now we find the second S and T again by using the probability of S times the probability of T. So it's going to be 0.3 times 0.4 and we get 0.12 as well. So these two values are the same, so therefore we can say that S and T are independent. Right, for part B, it says find the probability of S and T. Well, this is just going to be 0.12, this middle part here, right? And for part 2, find the probability of neither S nor T, so it's going to be this 0.42 value here. So the second part is relatively easy, it's just more importantly the first one's showing that they are independent. Okay, let's just try one more. So we have given that A and B are independent, find the two possible values of P and Q. Right, so we have P inside and Q outside. So we know that independent, that means that P, but that's the inside part, right? It's going to be this product of probability of A times the probability of B, like this. Okay, so we can say that probability of A is going to be this 0.42 plus P. Probability of B is going to be equal to 0.11 plus P. So therefore I can say that P is equal to 0.42 plus P multiplied by 0.11 plus P, like this. Which now I can expand the bracket. So you get 0.462 plus 0.53p plus p squared is equal to p. I'm going to bring the p on the left hand side to the right hand side, giving me 0 is equal to p squared minus 0.47p plus 0.0462. Now you notice this is like a quadratic equation, right? So you can use the quadratic formula or try and factorize it to find p. And what you get is p is 0.14 or it's going to be p is 0.33. So there's two values of p. To find q, well, I can just plug it into either one and q will just give me 0.33 or q will give me 0.14 like this. Okay, that's how we use the fact that the two events are independent to create a formula.